This problem is page 867, number 23. And the directions tell us to find the volume of the solid formed by the net. So we are looking for volume here. So what you have to do is you try to fold this together in your mind. You're going to be folding on the dotted edges. And when you fold it together, you're going to have a triangular prism in which the bases are the two right triangles. So you're going to have something that looks similar to what I will draw over here to our right. All right, now on that we see that as we fold it, we have, and I did not draw it as pretty on scale as they have. Let's see, I've got to come across here 31.4. Okay. That is my hypotenuse. I've got my right angles here. We want to put those in. When I have those right angles, let's see, my height then is going to be 20. And the 14 is going to be here. So if I want to find the volume of a prism, any prism that I have to find the volume of, since this is a right triangular prism, I'm going to use that the volume is the area of the base times the height of the prism. Now again, B is the area of the base. H is the height of the prism itself. The bases in a prism have got to always be congruent in our regular prisms, but we're going to have congruent, parallel bases. So our bases are these right triangles. And the height is the height of the prism. So that's going to be our 20. All right, so for our formula, uppercase B is 1/2 the base times the height of the base, and then times the height of the prism. So let's fill in our values. When you have a right triangle and you are trying to find the area of a right triangle, you can always, and I say should always, if you want the easiest approach, use the two legs that form the right angle as your base and your height. Your base and your height, when you take a triangle area, must always be perpendicular to each other. So what I've got over here, I've got the 14 as one of my values, but I have to find this missing leg right here. Okay, now if I've got 31.4 for the hypotenuse of one right triangle, it's going to be the hypotenuse for both right triangles. So I'm going to use the Pythagorean Theorem. 31.4 squared equals 14 squared plus x squared. Let me grab my calculator. I've already even locked that drawer. Let me open that up. Here we go. Okay, so we've got 31.4 squared. when I put it in my calculator, is going to give me 985.96 equals 14 squared, which is 196. And that equals, or that in addition to my x squared will be my Pythagorean theorem. So if I take my 985.96 and subtract 196, I'm going to get 789.96 is x squared. So let's take the square root of that. And I'm going to get for my x an approximate answer of 28.1. So over here, I'm going to put that 28.1, since now I'm finding, with this, I am finding the area of one of these triangles. 1/2 its base times its height, which we just found. Now I'm going to multiply that by the height of the prism, which is the 20. So back to my calculator, I'm going to have 0.5 times, 14 times 28.1 times 20. And hopefully that will give me the answer that I was looking for, and it does. It's approximately 3,934. And we're looking at volume, so we're looking at cubic centimeters. Okay? So to kind of recap this one for you, we fold up the box to see what type of shape it forms. And it forms this shape here. By seeing what kind of shape we have, the prism, not only do we know which formula to use, that the volume is the area of the base times the height, but it also allows me to pick out what the bases are for this prism, and they are the two right triangles. We knew the hypotenuse and one leg of the right triangle, so using the Pythagorean theorem, we found the missing leg. When we find the area of a right triangle, when we have 1/2 the base times the height, the base and the height must be perpendicular. So with a right triangle, we can always use the legs that make or create or construct the 90-degree angle. Okay, so I'm going to use 1/2 my 14 times my 28.1, and then I'm going to multiply that by the height of the entire prism, which was given to be 20. Again, we had to glean from the drawing, but we had to see how we folded up to get the height. Remember, the height of the prism is always going to be the distance between the two bases. That's a perpendicular distance. Okay, I hope that helps you on number 23 a little bit better. If that's not any more clear than the explanation that I copied from the book and pasted, make sure you let me know, please, before you take your test, and I'll be happy to try another approach to try to help you with that one. Okay, now I'm going to move over to page 885 and look at the last two with you. All right, let's see. We have to find two measures on each of these, don't we? We have to find the surface area and the volume of each solid. Now on 29, as I said in my email, I posted that one, that the corrections for that one, and the work all worked out for you, but it's got a green circle around the problem number, so you could also click that green button in your textbook, and it should work out and explain how to find number 29 for you. So that's another resource, as well as I'm about to do it for you. So the first thing that we're going to find here is the surface area of this particular drawing. So let's break it down and see what we need. Now with surface area or total surface area, what we want to look at are surfaces that we can touch. So this piece in here is not a touchable piece, so that's not going to count in to our surface area. So for the surface area, I'm going to look at this bottom piece first. I've got a cylinder. I have a right cylinder. So I want to find the lateral area of the cylinder, but this time I'm only going to add one base to get my total surface area, because again, this piece in the inside is not a surface that I can touch. Excuse me, I've gotten hoarse throughout the day, so I've kind of got the raspy cough. I'm sorry about that. Okay, so my surface area is going to be the circumference of my base times the height. So for this bottom piece, I'm going to have 2 pi r h, that's the lateral, plus just one base, that very bottom base. So plus 1 pi r squared. And that's going to give me that surface area for the bottom piece. But if you look at the top piece, I'll put it in red, you have the dome of a hemisphere. So the surface area of a sphere is 4 pi r squared, but I just have half of that, so I'm going to divide that by 2 and have 2 pi r squared. So as I pull all this together, I'm going to have 2 pi r h plus pi r squared plus 2 pi r squared. And just to make my arithmetic a little bit easier, I'm going to put these two together and make that 3 pi r squares. So let's see, we're going to have 2 pi, the radius is 4, the height is 5. And again, we've already said the radius is 4. So that's going to give me 20 times 2, which is 40 pi, plus 16 times 3 is 48 pi. So I've got 88 pi. And since it says nearest tenth, we know we need to put this in the calculator and see what it rounds off to. So I'm going to have 88 times pi, and I'm going to get approximately 276.5. And since I'm doing area here, this is going to be square inches. So there's my surface area. See if I can kind of divide these off. Okay. Now it also asks for the volume of that exact same solid. So to find the volume of the lower piece, what we need to do is find the volume of the cylinder. And the volume of a cylinder is always the area of the base times the height, but the base is a circle. So my area of a circle is pi r squared times h. Then the volume for my sphere is going to be 4/3 pi r cubed. But I've got to take half of that. So that's really going to be 2/3 pi r cubed. So again, pulling it together, the bottom part plus the top part should give me the volume of that entire solid. So let's plug in what we know. Our radius remains 4 and the height is 5. 2/3 pi, and again r cubed. So we're going to have 16 times 5, which is 80. So I'm going to have 80 pi here. Then over here I'm going to have 4 cubed, which is 64. So 2/3 of 64. Let's see if I can do that without it getting too ugly. I want to hold as many places in my calculator as I can before I round off. So 64 times 2/3, so 64 times 2 equals, and I'm going to divide that by 3, okay? And I'm going to hold that value in my calculator. Second answer times pi. And I'm going to get about 134, 0.04, so I'm not going to round it. So 80 pi is 251.3 plus 134 gives us approximately 385.3. And since this is volume, this is going to be cubic inches. That's a lot to take in, I know, when you can't interject questions along the way. So I hope that that was okay for you. Let's look at the last one. Again, we're finding a surface area here. So we're going to find, I'm going to find the entire surface area of my prism, and then I'm going to cut out this top circle. Okay? The entire surface area of my prism, and I'm going to take out that circle so that I have taken off the surface of the prism that's no longer touchable. Oops. Well, it could be that my pen is dying. No, it's okay. Alrighty, here we go. So my surface area for a prism, let's see, what does it tell me about the prism? It doesn't tell me it's a square prism. Let me look in the book and see what other directions I have. Okay, after I've looked at this, I see that they want that base to be a square. I think that that probably could have been indicated a little bit better. So in other words, this is 10, and this is 10, this is 10, this is 10. Again, that I don't think that's very clear, but that's what they intended there. Maybe that's where you were getting tripped up. We'll see. Okay? So, I'm going to, that's exactly what I said I wasn't going to do, isn't it? I'm going to find the lateral area and add to it the two bases. This is how I'm going to choose to do it. This may be a little different from what they did. Okay, so to find my lateral area, that's the perimeter of the base times the height, plus the two bases. Okay. So the perimeter of my base, I've got 4 sides and each is 10, so that's 40 perimeter times a height of 13 plus my two bases, and my bases are both 10 by 10s. So handy dandy calculator again, I'm going to say 40 times my 13 gives me 520 as my lateral area, plus I have 200. So I have 720 as the entire surface area of the prism, even if that little scoop was not taken out of there. Now, the scoop, however, was taken out of there. So what I want to do is remove from that top base the circle that's in there. Okay, this is the piece I'm taking off. So I'm going to have 720 removing the circle. So 720 removing a pi r squared, when in fact the r is halfway across the prism, so that's going to make my radius 5. So 720 less than 25 pi. So that's going to give the prism's contribution to the surface area, 720 minus 25 pi, 640 641.5. Okay? Now that 641.5 includes the bottom, the left, the right, the front, the back, and these little corners. But this dipped down place here, this hemisphere has surface to it as well. So I've got to take the 641.5 and add to it the surface area of the hemisphere. So 641.5 plus half a sphere, so half a 4 pi r squared. I'm going to clean that up because I don't want that to be confusing being so marked up. Okay, so I'm going to have 641.5 plus 2 pi 5 squared. 5 squared is 25, so it's going to be 50 pi. When you've got all of these decimals and so forth, it's real easy to lose confidence in your mathematics. Okay, let's see how this does. 641.5 plus 157.1 is going to give us about 798.6 square centimeters. Okay, so we did a pretty good job there with our surface area. Now for the volume. For our volume, to me, it looks like it's going to be a little bit easier. I haven't gotten into it yet, but right now, my thinking is it's going to be a tad easier. Let's see if I need to move this up so we have a little bit more room. Yeah, that helps. Okay, so for my volume, I'm going to take the volume of my whole prism. That whole prism in there is going to be, I'm being careful. If I put my hand at a certain place on my iPad, it cuts off the video. So I'm trying to be careful. Okay, the volume of my prism. And we're going to scoop out, so to speak, half a volume of a sphere. Okay? So the volume of my prism is going to be the perimeter of the base, the area of the base, which is 10 by 10, or 100, times the height. And from that, we're going to subtract half of 4/3 pi r cubed. So we're going to have 1,300 minus, okay, let's see, that's going to cancel and give me 2/3 pi, and 5 cubed is 125. So I'm going to have 125 times 2/3, and then that times pi. I wish you could see my calculator entries as I do this. I don't know a way to do that yet on my iPad. So I'm getting 261.8. So let's subtract 1,300 minus 261.8, and that gives us 1,038.2 cubic centimeters. Okay, and that's those 3 problems. I hope that helps you out, and please let me know if you have any other questions. Thank you.